Okay, so it's time to explain the Born statistical interpretation of the wave function. That what's a wave function and how we will be able to calculate its nature for the quantum mechanical particle. So let's start with this one. Let me first do an experiment. And this experiment I do for a classical particle. So if I am having a source of particles which is emitting some particles, and those particles are passing by a slit. This is one of the representation, means it is having an opening here and another opening at this point. These are called slits. And I am having a screen here, and I am having a screen here. So let's say this one is slit A and this one is slit B. Or if you don't call slit A, B, you call slit 1 and 2, it's up to you. If I close slit B is closed, only slit A is open, then what will happen? Particle will come from here, will pass through this slit and will strike here, means maximum here just in front of it, and this will be the distribution of the particles. And if I close slit A and I just open this one, then in front of it, it will have the maximum number of particles which will reach, so it will have its distribution, the maximum here. Right? My drawing is not that good, but you can see something here. So this I will call, this is intensity 1 and this one is intensity 2. Intensity 1 and 2. Now when both of the slits will be open, what will be the result of it? When both slits are open, particles will go through both of it. It means it will be the sum of this and this. So earlier the intensity was I1 and then intensity I2 was added with it, and it gave us the total intensity I, and the sum of it will be actually like this, that you will have something like this. Now it's not very symmetric, but this central point will be this one. This will be actually I, the total intensity. Clear? This is the story of the classical particle. The story of a classical particle. And now, if I do this thing for the quantum mechanical particle, what for quantum mechanical particle? Now the very first thing, I will write the quantum mechanical particle. Let's say the particle which are going through there, and for the quantum mechanical particle, I say, let's say psi 1, and the one which are going from the other is psi 2. The particles which are going from slit 1, psi 1, and the particles which are going from slit 2 are psi 2. Then you know about the quantum mechanical particles. The quantum mechanical particles are written as the combination of real and imaginary, and that I will explain a little bit more. So I can write the wave function psi 1 is the amplitude, means the coefficient in front of it, and then the oscillatory portion, which is I, let's say I write alpha 1. What is e power I? You know the Euler relation. The Euler relation is that e to the power ix is equal to cos x plus I sin x. These are the oscillatory functions. This one is the real component and this one is the imaginary component when I is with it. Sin x itself is real, but when I is multiplied with it, it becomes imaginary. And this one is the Euler relation, so I write for psi 1 like this, and for psi 2 is the amplitude of psi 2 multiplied with the oscillatory function with it, with the oscillation. We write our quantum mechanical particle like this. Now what will be the net intensity? Net intensity I will be equal, you know about the relation between intensity and amplitude. If you write a wave, like you write a wave like this, let f of x, for example, a function. I am not writing wave function but a function like a sine kx. Now I am not writing the t portion with it, but only the space component with it. Like kx plus omega t plus phi. Phi gives you the phase, omega t gives you the, let me write omega t. This is the complete description of a wave function. Now this is the space term, this is the time term, and this is the phase of the wave. If I neglect this one and this one, then f of x means here will be t as well, f of x t. Then f of x will be equal to a sine kx. Now this wave, this is a wave function, this is a function, this is a wave. This wave is having some amplitude, which is called this A. And then this domain is actually giving you the information about the wavelength of this. Because this K we call the wave number, which is 2 pi over lambda. This domain should be dimensionless. So X is length, K should be 1 over length. You see K is 1 over length here. So this one is becoming dimensionless. Now A is the amplitude of this wave. What is the relation? This we call the coefficient, this we call the amplitude. What is the relation between the intensity and the amplitude of a wave? You know this relation? Intensity of a wave. One is the energy of a wave. As earlier we discussed, energy of a wave is actually dependent on lambda, which is the wavelength. The shorter the wavelength, the greater will be the energy of the wave. It is related to E equal hc over lambda equals h nu. Nu is the frequency. E is directly proportional to the frequency. More the frequency, more will be the energy. Larger the wavelength, less will be the energy. So this term is actually controlling the energy of a wave. What the amplitude is doing? Amplitude is dealing with the intensity of a wave, right? Not the energy of a wave. Like one wave, you plot, this is one, for example, sine wave. It is having this much wavelength from here to here. And this is called the amplitude of the wave, right? Its wavelength is from here to here. And this is called the amplitude of the wave. Now if a wave comes in with a more wavelength, then this wave will have less energy. If the wave comes with a less wavelength than this one, it will have more energy than this wave. But if a wave comes in with the same wavelength but different amplitude, what property will be different between these two waves? Like this one is having amplitude this much and this is having almost double amplitude. The property of the wavelet will be different, will be called the intensity of a wave. This wave will have now more intensity compared to this wave. So the intensity is proportional to the square of the amplitude. So amplitude of a wave gives you the intensity of a wave. Similarly here, when I write intensity of a wave, then I will write psi mod square. Clear? I will write psi mod square. Now psi is equal to the sum of psi 1 and psi 2, and I will write mod square. Now you know about how to calculate the square of a complex number, because here our wave function we have written in the form of a complex number. Complex number means iota is involved there, imaginary number is involved there. So how we will write the square of a complex number? You know that if y is a complex number, then the square of y is actually equal to the complex conjugate of it into y. Not like y dot y. You know this fact. For a non-complex, y square will be equal to y dot y. But for a complex, it will be equal to the complex conjugate of it and then the number. So what about here? This will be equal to the psi 1 plus psi 2 complex conjugate of it and then multiplied with psi 1 plus psi 2. Clear? And you know that how to multiply such thing. We will write this thing that intensity is equal. This will be equal to psi 1 conjugate plus psi 2 conjugate of it, multiplied with psi 1 and psi 2, like this. And here is a dot product. You write in terms of cos theta. Sub psi 1 conjugate in psi 1. What it will be? You multiply this with this. It will become psi mod square. This will become psi 1 mod square. Plus psi 2 with psi 1. Okay, let me write it out here. Psi 2 with psi 2. It will become psi 2 mod square. But there are some additional terms as well. When psi 1 conjugate will be multiplied with psi 2 and psi 2 conjugate will be multiplied with psi 1. So we will have this one is psi 1 conjugate with psi 2 and then let me remove this dot so that it don't create any confusion for you. They are just simple multiplication. Psi 1 plus psi 1 psi 2 plus psi 2 psi 1 psi 2 conjugate psi 1. Now this one is equal to this plus what is psi 1 conjugate? Psi 1 conjugate from here is this one and you know in conjugate you change the sign of I. So it will be psi 1 e to the power minus I alpha 1, and psi 2 will be psi 2 and e to the power plus I alpha 2. Similarly, what about this one? This will be psi 2 and e to the power minus I alpha 2 and psi 1 and e to the power I alpha 1. So I can write that intensity is equal to psi 1 mod square plus psi 2 mod square plus, what about this one? Psi 1, psi 2, they are being multiplied. So their mods are there. Here is psi 1, no, they are magnitudes, psi 1 and psi 2. So I can write that they will become equal to 2 times, okay. Let me write them as common from them. So psi 1, psi 2 mods, they are common from them because now they are just magnitudes, and I can write that the rest will be, it will be e to the power I alpha 1 and I alpha 2. So it will be this one multiplied with this one. What it will be? It will be the sum of these two. So I will be taken as common and alpha 2 minus alpha 1. What about here? This will be common, this one is common, so this will be alpha 1 minus alpha 2. So I can combine them and I can write that this will be e to the power I alpha 1 minus alpha 2 and plus e to the power, okay, plus e to the power minus alpha 1 minus alpha 2, and this will be closed.